The data in the table are the average daily high temperature in degrees Fahrenheit in Bozeman, Montana. We're asked to define variables and adjust the data. In the month column, replace the name of the month by the number that represents the month in the year. And for example, April is the 4th month of the year, so replace A by 4. So I'm going to let M represent the numerical value of each month. And then I will let capital T represent the average daily high temperature in Bozeman, Montana. And the units on that are in degrees Fahrenheit. Alright, so now create a table here. So we're going to adjust this table. And so I will let M versus T. And so since April is the 4th month, 4, 56. 5, 64. 6, 74. 7, 82. 8, 82. 9, 71. Now we're asked to graph the data on a scatter plot, and are the data in a quadratic pattern. Alright, so I recreated the table. M versus T, so I'll put M here, T here. Alright, so now I'll just use a standard. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. I can fit them all, so alright, and temperatures go from 56 to 82. So let me put a break in the axis, and we'll start at 50, 55, 60, 65, 70, 75, 80, 85. And now we'll plot some points here. Alright, in month 4, we have 56. In month 5, 64. In month 6, 74. In month 7, 82. In month 8, 82. And in month 9, down to 71. So do we have a quadratic pattern? Well, looking at this data, it does appear to be roughly quadratic. We see that it increases and then decreases. Okay, so the data appear to be quadratic. Okay, so remember, quadratic implies that the graph is a parabola, and we see from the data that there's an increase and then a decrease, and so a parabola is reasonable. A quadratic model for the data is T is equal to negative 2.41 m squared plus 35.25 m minus 48.76, where the input m is the month of the year and the output T represents the average daily high temperature. Use the model to predict the average daily high temperature in Bozeman, Montana in March. And we're then asked to compare the prediction from the model to the real average daily high temperature of 46 degrees Fahrenheit. And we're given a hint to first convert March to its corresponding month number. So we will let, let's see, so March means M is 3, since March is the 3rd month of the standard year. So then the temperature, according to our model, the average daily high temperature in March would be given by negative 2.41 by 3 squared plus 35.25 by 3 minus 48.76. All right, so I'm going to use a calculator to calculate this. And I get 35.3. So here's what this says. The model predicts the average daily high temperature to be about 35 degrees Fahrenheit. Compare it to the real average daily high temperature of 46. This is lower than the real average high temperature. And part D, where is the vertex of this model? And interpret the meaning of the vertex in terms of the average daily high temperature. Alright, so recall that to find the vertex of a quadratic model, we had this tool that said that the x-coordinate of the vertex was given by negative b over 2a. Well, instead of x, we now have m. So let's use that. The m value of the vertex is given by negative and then 35.25 over 2 times negative 2.41. Alright, so let's go through that calculation. So that's negative over negative is positive. 35.25 divided by 2 times 2.41 gives me 7.31 approximately. Alright, so that's the x value of the vertex, and now about the y value. Okay, so not y, but t. The time value of the vertex, we will now substitute 7.31 into the model. So I'd have negative 2.41 by 7.31 squared plus 35.25 by 7.31 minus 48.76. Alright, we go through that calculation. Alright, I go through that calculation with my calculator and I get approximately 80.14. Alright, so what is this saying? In 7.31, that's July, so let's say about mid-July. The average daily high temperature is about 80.14 degrees Fahrenheit.